Okay, good evening to everyone. I think I shared the slide. Now, I think it is visible for you. Okay. So now the next problem uh, in predicate calculus. So prove the implication for every x p of x implies q of x. So this is the first premises. Second one is for every x p of x implies sorry r of x implies negation q of x imply for every x r of x implies negation p of x. Okay, so first I will take this premises or this premises. I will take this one for every x p of x implies q of x. The rule p. From step 1 to step 2, I am using rule US. So I can write this is true for every x. That's why I'll write for this is true for p of a implies what q of a. And then I'll use the second premises for every x r of x implies negation q of x. From step 3 to step 4, again I am using rule US R of A implies negation Q of A. Next, from 4 to 5, I used contrapositive. Q of A implies negation R of A. And then 2 and 5, P of A implies Q of A. 5 is what? Q of A implies negation R of A. Combining 2 and 5, we will get what? P of A implies negation R of A. Now again apply contrapositive to 6. So R of A implies what? Negation P of A. So I get step number 7 from the combination of these two. For every, that's why I'll put what? For every x, R of x implies negation P of x. So that is the conclusion here. Okay. Use indirect method to prove the conclusion. There exists x q of z follows from the premises for every x p of x implies q of x, and there exists y p of y. So here you should assume what? Negation of the conclusion. What is the conclusion? Uh, there exists z q of z. You should assume the additional premises, and then I will take this negation inside. So there exists is changed into what? Every z negation of what? Q of z. So from 2 to 3, I use rule US. So this is true for every z. So that's why it is true for what? Particular A or particular B. So I will take A. So negation of what? Q of A. Okay, next I will take this premises. There exists y p of y. Step number 4. Now 4 to 5, I am writing P of A. Okay, but already A is used, but it is used for what? Negation Q. Okay, but here I am using for what? P. So that is possible. Okay, because this is for already it is used for P means then you cannot use again. You can't use. Okay, for already I told maybe the 2 classes before. Okay, here there exists y p of y. Here what? Negation q of a. Okay, so from 4 to 5, I have ruling using rule es. I have what? P of a. Okay, now suppose if you have any doubt, you can use, but this is not a problem in this problem. Suppose still you have a doubt, then you can write this is step number 1. This is what? Step number 2, and then this is step 3, 4, 5. That is also you can write if you want. But if you write, so everything is correct in this procedure also. Now, up to 5, I explained. From 4 to 5, I got from where? Rule ES. Okay. So from 2 to 3, I am using rule US for what? Negation Q. Okay. So here it is true for every Z. That's why I'll write for what? A. But here also I used A, but I'm using for var. P for P of A. Here what? Negation Q. So both of them are what? Different. Okay. Next, P of A and negation Q of A. So this is P comma Q implies what? P and Q. Next, from here to here, I used De Morgan's law. I'll take negation outside. If I take negation outside, then you'll get what? Negation of P of A or what? Q of A. Okay, and then 7 to 8, 8 negation is there. Okay, this is P, okay, or negation P, or Q means negation of negation P of A. That is P of A implies what? Q of A. And then I got step number 8. Okay, step number 8. Okay, okay. Now I am using what? The premises, given premises. For every x, P of x implies Q of x. Rule P. From 9 to 10, I am using rule US. So it is true for every x. So it is true for what? Particular A. P of A implies Q of A. Now 11 is I'm getting from 10 and 8. This is actually P. This is what? Negation P. So P comma negation P is what? P and negation P. P comma Q is what? P and Q. Similarly, P comma negation P is P and negation P. So that is a false. So in that method, I assumed the negation of the conclusion is additional premises. This is the conclusion. And finally, I'll get what? Contradiction F. Okay. So wait. Okay. Now we'll move to the next problem. So for every x, P of x or Q of x implies for every x, P of x or there exists x, Q of x using the indirect method. So assume negation of the conclusion is an additional premises. Negation of for every x, P of x or there exists x, Q of x. So this is rule P, additional premises. And then from 1 to 2, I am applying De Morgan's law. So negation of, if I apply De Morgan's law, I will get what? Negation of every x, P of x, R is changed and the negation of there exists x, Q of x. And then from, I got 3. If I take this negation inside, okay, if I take this negation inside, for every change of there exists x, negation P of x, and similarly I'll take this negation inside, there exists is changed to every x, negation Q of x. Now this is considered, this is P, this is Q, so P and Q, you can write what? P, this is P, and you can write what? Next step, you can write Q. Now they will use here from 4 to 6 the rule ES. Okay, rule ES, because this is there exists x, negation P of x. Okay, so from 4 to 6 I am using rule ES. This is true for some particular x, that's why negation P of A. And 5 to 7, this is true for every x. Using rule US, I am writing negation Q of A. Now P, totally this is P, this is Q. P comma Q implies what? P and Q. So again, I will take using De Morgan's law, I'll take negation common. So P of A or what? Q of A. So now use the given premises. Okay. For every x, P of x or Q of x. Okay. This is, and then from here to here, rule US, that is P of A or Q of A. Now this is what? Again, P and sorry, P. I think here not R, here should be and. Okay, P of A or Q of A, and this is what? Negation P of A or Q of A. This is a typo. This should be and. So this is look like a P and negation P is false. So there is one more column. Actually, this column contains two there exist. Okay. So usually this type of problem is not asked in the examination. But anyway, okay, I will explain here. So there are three premises. Okay, this is the first premises. This one is a little bit lengthy. This is second one. This is the third one. This is the conclusion. So first they are assuming there exists x. P of x implies what? For every x, P of x or Q of x implies R of x. I think they missed here one more bracket here. One more bracket. So from 1 to 2, they are using rule ES as well as rule US, both. So here I am using A. For rule ES, I am using what? A. For rule US, I am using what? B. So here B, here also B. Next, there exists X, P of X. So this is rule P. From 3 to 4, I am using what? Rule ES. Already I used A, but there also I used what? There exists X, P of X. Here also there exists X, P of X. So then you can use in this case. Okay, so both of them are there exists X, P of X. So from 3 to 4 I used the rule ES, and next from 4 and 2. So P of A, P of A implies this portion. So you will get this portion. What is this portion? P of B or Q of B implies what? R of B. You will get it. Next, there exists X, Q of X. That is the third premises. From here to here, I am using what? Rule ES. So maybe here already you are using B already. But here you are using Q of B. So maybe you can use 6 and 7. Okay, before this one, before the first one. Okay, so 6 and 7 you can use, because already B is used for what? Q. So again that is true for what? For every you are using. Okay, so it is better to use there exists X, Q of X before this premises. Okay, so then you can write Q of B. After that you can write this one, and then you can write this rule. Use rule what? ES and US. It's my suggestion. Okay, now I got Q of B. Okay, now P of A comma Q of A. You can write addition. Sorry, yeah, not P of A Q of B. Sorry. Okay, yes, actually Q implies, sorry, P implies P or Q. P implies P or Q. That is addition rule. Okay, well, I'll write here. P implies P or Q. This is addition rule. Similarly, Q implies what? You can write what? P or Q. So this is addition rule. Now here, up to step 7 I explained. Okay, so now Q implies Q of B implies P of B or what? Q of B. So using 7 and addition. Okay. Now 5 and 8. Okay. So yes, this is actually P. P comma P implies Q is what? Q. Q. What is P? This is P. Totally this is P. And then this is what? P implies Q. What is Q? R of B. So I'll write R of B here. Now I got ninth step from the combination of what? From the combination of there exists X, because ninth step it involves what? Ninth step involves 8 and what? 8 and 5. Okay, wow. 8 and 5 of 5. 8 and 5. Yes, 8 and 5. But in the eighth step, you have Q of B. So I got Q of B from where? 6. Okay, and this one I got from what? There exists. Okay, wow. So that's why R of B I got from the combination of there exist. So that's why I'll put what here. There exists X, R of X, and then here you need there are two. One is R of X, and another one is R of Y. That's why I have R of B using rule EG. I am getting what there exists X R of X. From this again I am using rule ES. I am getting what R of A, because I need two of them, R of X and R of Y. That's why R of B and R of A, I am writing like this. So from 9 and 11, so P comma Q implies what? P and Q. Now, uh, so this is I get from combination of there exist. Okay, so that's why first I will fix. I keep fix A, and then I am varying B. So instead of B, I'll put what? Y. So there exists Y, R of A, and what? R of Y. Now I am also varying what? A. So instead of A, I'll write what? R of X, there exists X. Already there exists Y is here. So R of X and R of Y. So this is little bit difficult, slightly difficult problem. So try to understand this one. Okay. Now I think maybe so I think it is visible. If it is not visible, I will increase the size. Okay. P of X with the statement X plus 1 greater than X. Uh, okay. What is the truth value of the quantification? There exists X P of X, where the inverse of discourse consists of all real numbers. Okay. So actually, P of X is a statement what? X plus 1 greater than what? X. So actually, P of X is true for any real number, because inverse of discourse is consists of what? Real numbers. So it is true for any real numbers. So the quantification there exists X P of X is what? Is true. They are asking whether what is the truth value of there exists X P of X. That means whether this is true or false. Okay, this is true, because this is true for our real numbers. Okay, next, what is the truth value of the following quantification? For every x q of x, where q of x is a statement x less than 2, and the inverse of discourse consists of all real numbers. Okay, so inverse of discourse of consists of all real numbers. Okay, now you can see here uh, x less than 2 is not always true, because if I take x is 3, okay, so this is false. Okay, so if I take x is 1, this is true, but they are telling what? This is true for what? For every x, but it is true, not true for every x. It is true for some x. Okay, so q of x such that x is less than 2, q of x is not true for every real number, because q of 3 is false, q of 4 is false. So thus for every x, q of x is what? False. Okay, second subdivision. For every x p of x, where p of x is a statement x square is less than 10, and the inverse of discourse consists of all positive integers not exceeding 4. So that means positive integers means 1. So if I substitute 1, it satisfies. 2 is also satisfies. 3 is also satisfies, but 4 not satisfies. Okay, well, so that means for every x p of x, here it is given clearly. P of 4 is a statement. 4 square is what? Less than 10 is, which is not true. So that's why for every x p of x is what? False. Suppose if we change the inverse of discourse. So again, if suppose if I take inverse of discourse consists of the positive integers not exceeding 3. So not exceeding 3 means 1, 2, 3. So in this case, for every x, p of x is what? 2. Okay. Next problem. What is the truth value of the following quantification? So there exists x p of x, where p of x denotes what? X greater than 3. And the inverse of discourse consists of all real numbers. Yes, actually this is true for some x. It is not true for every x, but here it is true for what? Only for some x. Okay, so there exists x p of x is what? True. Okay, next, there exists x q of x. Q of x is statement x is equal to x plus 1. So uh, the inverse of discourse consists of what? Set of all real numbers. But x equal to x, we know that. So that's why there exists x q of x is what? Okay, there exists x q of x is false. Okay, q of x is equal to yeah, x is equal to x plus 1. Since q of x is false for what? Every real number. So therefore there exists a q of x is what? False. Okay, the next problem, express the statement. So these are the 2 more questions. Okay, and also you can refer the previous year question papers, university question papers for 2 marks. Express the statement. Every student in the class has studied. Okay. So every student, express the statement. Every student in the class has studied calculus as a universal quantification. Okay. So already we every student in a class. Okay. So so already we discussed similar type of problem. So everyone in the class studied Java programming like this. So for this, so every student, okay. So for every x, s of x, or you can put c of x. C of x means what? S of x here they will take x is a student in the class, or you can write c of x. X is a student in the class. Okay, for every student. That's why every x. Okay, s of x implies what? You can write calculus c of x. You can write. So don't take both of them are C. So okay. So you can write S of x implies P of x, or S of x implies what? C of x. Okay. So you should tell what is S of x. S of x is a statement. X is a student. X is a student in this class. And the P of x means what? X studied calculus. X studied calculus. X, okay. So, and also tell what is the inverse of discourse. Inverse of discourse, and inverse of discourse is what? Set of all students. Set of all students. At least you should write for every x, s of x implies what? P of x, where s of x is a statement, x is a student in this class, p of x is a statement, okay, where x has studied calculus. Okay. Okay, next problem. Which of the following proportions are equivalent over the inverse of integers? So first one, 0 less than n square less than or equal to 4. Second one is 0 less than n cube less than or equal to 8. Third one is 0 less than n less than or equal to 2. Okay, so they are asking inverse of discourse is what? Inverse of discourse is integers. Either they are asking which of them are equivalent. Okay, so first I define what is the inverse. Inverse consists of all integers. Okay, So P of n such that n is an integer such that uh, this condition, okay, 0 less than or equal to n square less than or equal to 4. Q of n is an integer again such that it satisfies this condition. 0 less than n cube less than or equal to 8. R of n such that n is an integer such that n satisfies this condition. Okay. Now, so the statement P of n has a truth value, okay, only when n is what? 1, 2, okay, n is 1, n is 2, n is minus 1, n is minus 2. So these four values, this is true. Next, Q of n. The statement Q of n has the truth value only when what? N equal to 1 and n equal to what? 2. What about n equal to 3? 3 means 3 power 3, 27. So it does not satisfy. And then R of n is true only when n equal to what? 1 and n equal to 2. 2 equal to 2. So the truth value of Q of n is what? N equal to 1 comma 2. Similarly, the truth value of R of n is what? N equal to 1 and 2. But the truth value of P of n is what? N equal to 1, 2, minus 1, minus 2. So and hence the truth value of Q of n and the truth value of R of n are same. Hence the statement Q of n, this is Q of n, this is what? R of n are equivalent. Hence the statement Q of n and R of n are equivalent to each other. And also finally P of n, okay, is not equivalent to either Q of n or P of n. So I think now you got how to prove two of them are what? Equivalent using the truth value. Okay. And then last problem. Maybe today this is the last problem. Tomorrow I'm going to start relation. So today logic is over up to this problem. Express the negation of the following statements using quantifiers and in English. Okay. First sentence. If the teacher is absent, then some students do not keep quiet. So first we will discuss A. Here I will take T represent what? The presence of the teacher. And the Q of X represent X keeps quiet. So the given statement is if teacher is absent. So if teacher is present, not T. Teacher is absent means what? Negation T. Then some students do not keep quiet. So some students, there exists X. Keep quiet means what? Q of X. I think here negation is missed. So there exists X. Negation what? Q of X. Okay, I'll write here. Negation T implies there exists X negation Q of X. There exists X negation Q of X. So this is the original statement. So we need to find what? We need to find express the negation of the following statement. So how to find the negation means, so negation of this one. So is equivalent to negation of P implies Q. Okay, so negation of negation T is what? T or there exists X negation of Q of X. Okay, now this is equivalent to negation of T or I'll take this negation outside. Okay, then this is there exists is changed into what? Okay, yes. If I take this negation outside, negation of okay, for every x Q of X. Now I'll take this negation inside. We'll get what? Negation t, and negation gets cancelled for every x q of x. To check it, negation t and for every x q of x. Negation t here, but check it, negation t and every x q of x. So this is a negation, okay, and you should tell, and you should write uh, in English also you should write. So what is negation t means? T means teacher is present. Negation t means teacher is absent, and symbol, and for every x q of x, that means what? All students are what? Keep quiet. Okay, so this is a negation. I think they done it slightly different way. So how? Okay, here actually negation. Okay, negation t implies there exists x, negation q of x, so is equivalent to negation t. So I think this is negation they will take outside. So then it will automatically change into what? Negation for every x q of x. Next to p implies q is what? Negation p or q. So negation of negation t is what? T, or negation for every x q of x. Now they are finding the negation for this statement. So now actually I found the negation of this statement itself. Okay, they found the negation of this statement. So negation of, because these two are equivalent. Okay, so negation of t or negation of for every x q of x. If we apply De Morgan's law, negation t and what? Negation gets cancelled for every x q of x. Okay, next B. All students keep quiet and the teacher is present. All students keep quiet means for every x q of x. Okay, q of x means x keeps quiet. Okay, all students keep quiet for every x q of x, and teacher is present. Teacher is present, not t. Now negation. We need to find the negation of this statement. So negation of everything should write. This is equivalent to apply De Morgan. Negation of every x q of x, or what? Negation t. I will take this negation inside. So every is changed into there exists x, negation of what? Q of x, or negation t. Now I should write in English. So some students, okay, do not keep quiet because negation q. Okay, negation q means x keeps quiet. Okay, okay, q of x. Here some students do not keep quiet because negation q. Or t means teacher is present. Negation t means teacher is absent. Now see, some other students do not keep quiet, or the teacher is present. Some other students do not keep quiet means there exists x, negation q of x. There exists x, c, yeah, there exists x q of x. Okay, some students do not keep quiet, or teacher is absent. Teacher is absent na negation t. Teacher is absent na negation t. C, negation t. So this is equal to, I'll take this negation outside. So we take negation outside. Negation of there exists is changed into every x q of x, or negation t. Now for this you can take the negation of negation every x q of x, or negation t. Apply De Morgan. So negation gets cancelled for every x q of x, and what? Negation of negation t is t. So what is the meaning of this? All students keep quiet and teacher is what? Present. Okay, the last one. So the last one is slightly different. No one has done every problem in the exercise. Okay, no one has done every problem in the exercise. So no one has done. Okay, so that's why they define d of x comma y represent x has done the problem y. So this is usually will not do like this, but here uh, for these types of sentence you should write like this. So no one has done every problem in the exercise. So there are two things. One is person, okay, no one, okay, no one, okay, or student, okay, I can consider, okay, and the another one is a problem. So that's why I'll take d of x comma y represent x has done problem y. What is the given statement? Okay, uh, actually for every y d of x comma y means, okay, suppose forget about just you have, I don't have negation, suppose, okay, for a moment you assume that there is no negation here. Okay, that means what? There exists x every y d of x comma y. So what is the meaning of some student? Okay, some students, okay, solved every problem, solved every problem. So that is the meaning. But I need what? I need if no one, okay, no one solved what? Every problem. So if I don't have negation here, then here you have what? Someone solved every problem, okay, but I need what? No one solved every problem. So that's why I'll put here negation. So negation of there exists x. So that means no one has solved any problem. So negation of the given statement is, so I will put negation here. So negation of negation gets cancelled here itself. So that's why I'll get what? There exists x every y d of x comma y. So that means what it mean? Someone has done every problem. Someone has done every problem in the exercise. So there is another method is also here. Okay, so this is the first method, aliter. So equation 1 can be rewritten like this. How you can write the rewritten? I think mm, okay, for every, I think they will take this negation inside. If you take the negation inside before, okay, yes, but you should write 1. Okay, you should write 1. So this is a crucial step. Okay, and then I think this is enough. Aliter is they will take negation inside there exist. So that is change there exists change into what? Every, and then you have this negation is here. Negation of what? Every y. Uh, if you take the negation directly from here to here, so this there exists is changed into what? Every, and this every is changed into what? There exists. So that's the meaning. So I'll take this negation directly to this d. That means for every x and there exists y, negation of what? D of x comma y. So next negation of this statement. Okay, so again negation. I'll put negation before this. So again I will take negation inside here. This every is changed into what? There exists. This there exists changed into what? Every, negation of negation gets cancelled. So d of xy. So that's why I feel this method is a little bit easier. Directly you are getting the answer. Okay. So logic is over. Uh, Tomorrow I'll try to take class on relation. So okay. So if you have any doubts, you can ask to me. Otherwise, we'll meet on tomorrow. Thank you.